Hello everyone, welcome to Engineering Archives. Let us look at the first learning problem for this chapter, force vectors. So before we start solving the problem, there are a few concepts that we should discuss, and these concepts will constantly be used to solve questions for this chapter. The first concept is the concept of vectors. So vectors are composed of two parts. Let's say we have a vector f. This vector f would be composed of two parts. The first part is its magnitude, and the second part is its direction. The direction of f is denoted by the symbol u, which means a unit vector. A unit vector specifies the direction of the vector f, and the unit vector has nothing to do with the magnitude of f, since the magnitude of a unit vector is always equal to 1. So let's say we have a force vector from point A to point B on this diagram. And let's say the question says the magnitude of the force vector is 100 newtons. So our force vector AB would be equal to the magnitude of the vector, that is 100 newtons, times the unit vector, And let's say the unit vector is negative AI plus BJ plus CK. So our force vector would be negative 100 AI plus 100 BJ plus 100 CK. The point is, in order to get a vector f from a unit vector and a force vector, we take their product, and that gives us the vector that we are looking for. Secondly, you will notice that in the previous chapter, they gave us force vectors, and with those force vectors they gave us the coordinate direction angles. And using those angles, we were able to find the components of the vector in the x, y, or z directions. While in this chapter, you will see questions in which they don't give us those coordinate direction angles, but instead they give us the length measurements for the angles. And we can use these length measurements to find the length vector. So first of all, we would be finding the length vectors. And once we have these length vectors, which are denoted by the symbol r, using these length vectors, we can find the unit vectors for those length vectors. And once we have those unit vectors, then we can find the force vectors by multiplying the unit vectors with the magnitude of the force. So this is a general principle that we will be following for most of the questions in this chapter. Now that we have all our concepts out of the way, let us start solving this question. The question says, express the position vector RAB in Cartesian vector form, then determine its magnitude and coordinate direction angles. So since this is a very basic question, all they want us to do is find the length vector in its Cartesian form, and after that just find its coordinate direction angles. So let's find the length vector RAB from the point A to the point B. In order to find the length vector, all we have to do is see their lengths in the respective x, y, and z directions. So in the x direction, we can see that the vector starts from the point A, and then it moves towards the point B, and the total length in the x direction is 6 meters, 3 on this side, 3 on the other side. But since its direction is towards the negative x-axis, we will put a negative sign. In the y direction, the length is also 6 meters. Oops, there should have been an I here, not a J. And lastly, in the z direction, the length is 3 meters. So now that we have our length vector, we can move on to find its magnitude. And in order to find the magnitude, we will just use the resultant vector formula. So the length of AB will be equal to under root sum of square of all the components. And this would give us 9 meters. So the magnitude of this length vector is 9 meters, which means the length of this line from the point A to the point B is 9 meters. Now that we have our magnitude, we can move on to find the coordinate direction angles. To find the coordinate direction angles, we would use the same formula as we used in the previous chapter. And that formula is cos theta of any angle from the x, y, or z axis is equal to the component of the vector in x, y, or z directions divided by the magnitude of the component. So let's say we are finding theta x first. So cos of theta x would be equal to the component of the length vector in the x direction. Well, that component is negative 6i divided by the magnitude of the length vector. The magnitude is 9. So once we take cos inverse of both sides, we end up with theta x is equal to 131.8 degrees. So you must be wondering, our length vector RAB does not even go through the origin. So where is this angle theta x on the diagram? Well, in order to spot this angle on the diagram, what you need to do is you need to draw a set of axes on the tail of the vector. So at A, we need to draw the x, y, and z axes. And the x-axis. So the angle 131.8 is the angle that this vector makes with the positive. It makes with the positive x-axis. So this angle is 131.8. Okay, let's move on to theta y. So cos of theta y would be equal to the component of the length vector in the y direction, that is 6, divided by the magnitude of the length vector. Once we solve for theta y, we get 48.2 degrees. And lastly, let's solve for theta z. Cos of theta z would be equal to the component in the z direction divided by the magnitude. And thus theta z is equal to 70.5 degrees. So this was a simple and easy procedure for this question. We would be using pretty much the same procedure for other questions, although those other questions would be a little bit more advanced. Thank you very much. See you in the next video.